All right, so today we're going to be solving systems of equations by graphing, and you're going to also be introduced to the special cases with systems. So to get started, it looks like from the first example here that you see, first of all, when we're talking about systems of equations, we're talking about two or more equations. For the purpose of Algebra 1 or Integrated Math 2, so if everything we're going to do this here, you're going to have two equations in the same variables. So you can clearly see here xy, 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 xy. So you can't be having one to have xy and the other to have a and b. It doesn't make sense. Also, if you're moving on with math, when you get to Algebra 2 or in higher level classes, you will probably going to be doing systems with more than two equations. But for this year, only two. So when you're hearing the word system, you're talking about two or more equations. So today we're doing graphing. There are more than one ways of solving systems, but today we're doing graphing. The first system, the two equations are solved for y. So I'm going to go in there and I'm going to pull out from each the m and the b because I have to graph. So if I'm looking at the first one, its slope is -3, which means -3/1. And I can also write it as 3/-1. And the b of the first is 2, which means 0, 2 would be my starting point. If you go to the second, since it's already solved for y, the slope of the second would be 2, which means 2/1, or I can put two negatives. And the b of the second would be -3, which really means 0, -3. So I need to transfer all that information to a graph. So give me 1 second. I did not create this graph. I created the other ones though. All right, so it's kind of small numbers here. So if you go up, down 5 units, we should be good to go. All right, so let me go ahead and start graphing the first one. I'll choose the black marker. So 0, 2 is right here. The slope tells me down 3, 1, 2, 3 to the right 1. And I can do it again, 1, 2, 3 to the right 1. Or I can go, according to this, I can go up 3, 1, 2, 3 to the left 1. So here is the first line. Second line. Start at -3, 1, 2, 3 down. Here we go. The slope tells you up to right 1, and I can repeat. Or I can go down to left 1. So there's your second line. So the purpose of doing all this is for me to graph on the same graph and check if I have a point of intersection. That's of major importance to me right now because I'm graphing to see if there's a solution, and the solution is the point of intersection. Well, for this specific system, I do have a point of intersection. It's right here. We call it POI, which stands for point of intersection, and in order for me to finish this, I need to put down that point. I'm going one right, one down. So it looks like if I did it correctly, this should be the solution. 1, -1. Let's go and check indeed that this is correct. If this is correct, this point should be satisfying both original equations. So if you take this blue point and you put in the first one, you should have -1 equals -3 plus 2, which is giving you -1 equals -1. True statement. Take this and put it in the green one. I have -1 equals 2 times 1, which is 2, minus 3. -1 equals -1. True. So yes, indeed, this is the solution to the system because the -1 that I got gives me a true statement for both. So here's what happened in the specific first example. We started with two equations. They were both solved for y equals, so I didn't have to do any extra work there. I pulled out the m and the b of each, and because the m's and the b's were both different, I was anticipated to get two different lines where they would be meeting at one point, and that's exactly what happened. Let's go to the second example. The second example, the equations are not solved for y, so I need to do that first. So if I take the first one and I solve it for y, I need to take this x over. Switching sides means switch the sign. And there we have it. So I'm going to put this in a box. So might as well finish this. The m of this would be the number in front of the x, which is -1. or I can put it as 1 over negative 1, and the b would be 4, which means 0, 4. So let's go ahead and plot this in to be done with that. So go up 4, and the slope is telling you down 1, right 1, down 1, right 1. Or you can go the other way, up 1, left 1. So here's the first line. I anticipate that the line would be decreasing because my slope is negative. All right, let me go choose a green marker and start work for the second equation. This is not solve for y. First step, take the negative x over. So if I take the negative x over, it means plus x to both sides. But I'm still not done because there's a problem here. There's a negative. So you can multiply everything or divide everything by negative 1, which makes you switch all the signs. All right, now I have it in y equals, so I'm going to box it. The m, again, is the number in front of the x. And the b is negative 3, which means the starting point should be 0, negative 3. So if I'm comparing this information here with this, I can clearly see the same slope, but different b's. So when you have the same slope and different b's, you expect, hopefully, to get a pair of lines that will never intersect. So let me go ahead and show that in the graph. Here is my negative 3, my starting point. Down 1, right 1, down 1, right 1, up 1, left 1, and so on. And it should be a straight line. Okay, these are a bit off there. So these lines are parallel because of the same slope at different b's, and they will never meet. So if I'm thinking about that point of intersection that we talked about before, well, it's not going to happen. So I have no point of intersection, which means here I have no solution. So anytime you have parallel lines because of the fact of not meeting, of not intersecting, you're going to have no solution when you're talking about graphing a system. Let's go to the third example. Again, I have to do work for the third example. Nothing is solved for y, so let me take this 2x over. Negative 2x. The 8 is positive because there's nothing in front of it. I have to get rid of the negative. Anytime you have to get rid of a negative in math, you multiply or divide by negative 1. And that makes me to switch all the signs. So here we go. I'm going to put this in a box. This is telling me my m is 2 over 1, or negative 2 over negative 1, and my b is negative 8, which means 0, negative 8. Now maybe I should go here by 2's. So 2, 4, 6, 8 down, that's going to be my negative 8. The slope is up to right 1, up to, I can go by 1 to the right direction. Okay, so it would be up 2 over 1, up 2 over 1, up 2 over 1, 1. So that would be my first line. I expect the line to be increasing from left to right because the slope is positive. Let me choose the green marker and start working on the second line. I have to take the 6x over, so minus 6x to both sides. I have to divide everything by negative 3. Clean that up. Y equals a negative over negative right here. Let me just show you here. As a negative, I'm dividing these two, and a negative over negative should be positive. So that would be positive 2x if you do your division. And then you have this over this. A positive or negative would be negative, and that would be negative 8. Something interesting is happening here. If you compare the two boxes, you see exactly the same thing. Maybe you couldn't see that at the beginning, but you see it now. So if you're trying to graph the same thing, you're going to get the same line. So I would put the dot here, it would be dot here, so it would be the same line. So when you have two of the same equations, you're talking about the same line, which means that any point on the one would satisfy the other. So this is like many solutions. Any point on one would satisfy the other. So if you're talking about the same line, you're talking about many solutions. So let's recap really quickly. Two different lines because the m's are different, the b's are different, therefore They will intersect at one point. Two lines, while I'm solving it for y, I see that same m but different b's. So because they have the same slope but different p's, their starting point would be different, but they're equal distant from each other the whole time, which means no solution for the system, no point of intersection. Then while I'm solving the last one, I have the same m and the same b. So they're telling me that I'm going to have the same line twice, which means many solutions. By the way, some people call this when I have the same line one on top of the other. These are called coinciding lines. Coinciding lines. And there you have solving systems by graphing where you have one of each case. So even though most of the times you anticipate two different lines, some very few times you can have the other different cases.